Okay, today I'm going to create some simple tiling pattern based on the honeycomb geometry. Let's try this out. I'm gonna make it from scratch, and I didn't practice it before, so it might take some time to do it. So let's try to create from the hexagonal tiles. Okay, let's define some sizes for this one. So EX and EY is the number of pattern again. Alright, let's set the number of X and number of Y. Okay. And for S, it's the size for the basic hexagon. Maybe I could keep it as 1. Well, right, then let's shift this so that the edges of hexagon will come to the center point of the hexagon. So how do I do that? Maybe I can move this like diagonally 60 degrees here. So, and the radius is 1, so the moving distance is 1, I think. You define by this one, since this should be the radius of the hexagon. So I just need to set the distance, the direction. Alright, let's create that direction using since this is okay, I think I can just rotate the y axis, y direction, using a vector rotation, using z as a rotational axis, and the angle I can rotate it 60 degrees, I guess. Let's try this out. Radians 60. Does it work? Was it right? Okay. Alright, let's try this. Amplify this vector with this radius and move the whole hexagon to this direction. Alright, looks good. Now maybe I could extract the point itself, the center point of the hexagon, then move that one instead of moving the polygon, because I don't think I need to use that. Alright, and maybe I could still use those curves. Alright, to make a three-dimensional weaving pattern. Alright, okay, let's think about how to do that. Okay, for the one that is selected right now, the green one, I could move those vertices which is on the odd index or even index to upward, and even the other one, the even number indexes, then to downward, move it to downward. So to do that, I need to know those point numbers which for each hexagon. Let's try to see it from this one. Let's hide this plane, just showing the curve. Okay. So there is a data tree for this, and let's see how it looks like. If I get the tree branch, the first tree branch, using tree statistic, tree statistics, and then just get the first one. Nope. Oh yeah. So this is the first column. So the branch represents the column, I guess. So that means I could I could think about how to move those right edge, right vertices for each column, either downward or upward. Okay, let's try to do that. Okay, so I have the tree statistics that shows all the paths, the branch paths, and let's make a series out of this, starting from 1. So let's get the length of branches, then you create the series, and then calculate what modulus with 2 so that you can check, you can create 0, 1, 0, 1 numbers like these. And if it's 0, I would like to move those points downward. If it's 1, I would like to move those points on the right side upward, and vice versa for the left one. Alright, so let's convert this 0, 1 to -1 to 1. So I'm just going to use the remap number, and for the target domain, I'm gonna use construct domain right, and set the minimum to -1, set the maximum to +1, like this. Alright, looks good. Alright, now it's the time to extract the control points for each hexagons and split it into right side and the left side. Okay, so I can get the control points using control point node, control point component, like this. And for each hexagon it has 7 points because it has endpoints and starting point. And let's check how to define which are the left one, which one's on the left side, which one's on the right side. I guess I could do that by calculating the angle with the x-axis for each hexagon, starting from the center point of the hexagon, create a vector which goes from the point to each point, from center point to each point, and calculate the angle between that vectors together with the x-axis. So the x-axis, if the angle is less than 90 degrees, then the point should be on the right side. If it's more than 90 degrees and less than 180 degrees, then that should be on the left side. Alright, so I need to get the center point for each hexagon, and I think this is the one that gives you the center point of the hexagon. Alright, so let's calculate the vectors from the center to each. Maybe I should graph this as well. Graph this and get the vectors. Let's visualize this to check. Yeah, looks good. Okay, now let's give a vector x to calculate the angle between two vectors. Alright, and what is a and what is r? Okay, just need a. And let's convert this to degrees so that it's easier to see. Alright, now I can check whether this is under 90 degrees or more than 90 degrees. So I will use the larger than or smaller than should also work. And right, 90 degrees. Okay, now I have those conditions, false or true. Okay. So next I would like to do what I would like to do is to combine those two informations together, and for each in order to move those right side and left side upward or downward. Okay, let's think about that. Okay, so for this one, let's split the list, not dispatch the list using this pattern and the control points. All right. Okay, and let's try to see which one's which. So this one seems to be the left side. This one seems to be the right side. So let's just move the right side for now. So for the right side, I would like to move as this rule. So if it's -1, I'm going to move downward. If it's positive, I'm going to move upward. Okay, so let's multiply this value with the value, how much you want to move upward or downward. So that's a parameter you want to set. Let's set the maximum to 1. And then convert this to z-axis, z vectors. And then right, let's check the data tree. Okay, so this has 10 values. This has, okay, I think I need to first of all graph this to give a 10 branches, and then I also want to convert this into 10 branches. So to do that, I'm going to shift this path to give 10 branches as well. Right, and move this points with this. Okay, might be moving too much. Right, like this. Okay, and pretty much do the same things for the left side one. So let's copy this together, and I'm going to move those points, but in this case I would like to move the other direction. So I'm going to multiply, or just use the negative, maybe right here, then connect it to here. Right, okay, that looks good. And after that, I want to retrieve this data tree path from here. So I'm going to use a unflattened tree component in order to get the original data tree structures. So this is the guide. This is the current tree. Okay, do the same for this one. This is the guide, and this is the tree. All right, and then weave back those points back together so that you can construct the hexagon again. So this was, well, let's just do it. We use weave to weave those together, and let's check if this works. Now after doing this, if I use the polyline, it should give you a hexagonal geometry. Ooh, nope. No, not this one. Polyline. Okay, it has some messed up geometry. That is, I guess, because you have to change the path to here, like this. Still not working. Okay, alright. I think I need to also use this pattern to here. Alright, that looks good. Now hide all those geometries. Let's also delete this one, hide these. Okay, that looks okay. Now now if I bring this back, which I used to move those diagonally, and try to move this one, and okay, maybe that should go other direction. Let me try using negative for this one. Okay, I might need to flip the direction which way it goes up and down, so I'm gonna make this, and to do that it might be a bit cumbersome, but I am going to say, let's say let's copy this, or copy these, to give right here, and replace this one to here, and this one to here. Alright, and for this one I'm going to move right here, and let's see how it looks like with those two patterns. Now it's a bit hard to see with the lines, but I think it has created some kind of weaving hexagonal pattern. Let's try to move this back, move this a little bit lower for the height. Okay, yeah, I can see that it has some kind of weaving pattern right here. Now after this, I am going to create a circle for each hexagon. So to do that, I think all the hexagon, okay, well, the problem is all the hexagon is not planar, so it might not be possible to create the really clean plane, really planar circle. But does it matter? It does. Let's see. If I if I create the final geometry as a mesh, that doesn't really matter. So if it's going to be surface, it's a bit problematic, I guess. Let's see. Well, in Rhino 7, I think you can use the subdivision, so it's no problem. So I'll just do the mesh. Let me do it in the mesh way. Shall I? Yeah. Okay, so for each hexagon, I have two hexagon pattern, weaving hexagon patterns, and for each hexagon, I am going to get the center point. Oops. Okay, not possible to get a center, so I'm going to get the this is a point list, so let's just remove the first point because first point and end point is equal, and then get the average, which will be an arbitrary center point. Do the same for the other list, which is this one. Oh, not this one, this one. Okay, and for this one, let's do a scale. Scale this one with this one as a center point. Check the data tree. Okay, and also set the scale to define the size of the hole. Alright, and do the same for this one. I'm going to give a scale with same. Okay, does it look correct? Nope, that is because I also need to move this one. Yeah. Okay. Okay, now let's combine this base hexagon for pattern 1 and scaled hexagon, and use a loft to create a ribbon like this, and do the same for the other pattern. So the first one here, second one scaled, use the loft. Okay, am I missing something here? Maybe the data tree is not equal. Alright, looks good. Now I want to maybe I can scale this a bit bigger. Okay, now I want to convert this into a more circular shape, so let's first merge them together, and then flatten it, brep join, and then from here I could convert this into mesh using something like simple mesh. Then I am going to use a component like Weaverbird in order to subdivide to make those hexagon more circular. So I guess I can use this cut mall subdivide. Okay, and the level, maybe I could set to 3 to make it more circular. Maybe too much. 2 is fine. Alright, starting to get looking better. Now let's try to visualize it using some colors. and set some colors here and hide the mesh edge, and voila, this is what I wanted to create. But it's a bit hard to see whether it's on the bottom part or on the top part. So let's also set some vertex color, and I'll finish this. Alright, so to do that, after I have subdivided, I am going to get the point position, vertex point position for each mesh, and deconstruct the vertex into x, y, and z, and I'm just going to get the z direction, which is going to be the height. So let's get the bounds of the height, then remap component to remap this z value with maybe 0 to 1 is fine, and then let's create a gradient. Oops. Let's give a gradient color value, a color component, and connect this to T, and let's set some color that you would like to visualize for top part and bottom part. So the bottom part, I guess I would like to make it darker. So for this pink one, I'm gonna make a dark red. And for the top part, I'm gonna make it maybe the middle red, and for the top part, I'm gonna give it a bit more pinky or white, something like this. Okay, let's see how it does look like. Now, in order to use this as a vertex colors, I'm going to use the color mesh, mesh colors, and maybe I could use the construct mesh instead. So vertex come here, F come here, and the color comes from here. Okay, doesn't really give any changes. Okay, that is because I have this one. So let's remove this. Alright, that looks much better. Okay, that might be too much contrast. Maybe yeah, this looks good. Blue looks good. For the darker color, it depends on your looks good. Alright, that's pretty much it. So you have control with the hexagonal size, which is the base size for each hexagon. You can set the x and y size, x and y number, like these. Alright, and then what was this? So this is the height for each weaving. If it's lower, it's gonna become more planary. Alright, and then you have this parameter to control the size of the circle. This looks interesting as well. Yep. Alright, that's pretty much it. Maybe I don't want the dark part to be that visible, so I might want to add one more color. Say set it as like these. Alright. Okay, that's it. Thank you. That was pretty easy to construct. Let's hide the grid. Okay, yeah, I like the pattern. I hope you like it too. Okay, thank you.